We're going to start all the way here with a line angle diagram, and we know that at each of these nodes we have carbons and hydrogens to complete the four needed bonds for each of the carbons. So if I start to write this out as a condensed structural formula, I know that this first one here is a carbon, and since it has one bond going here, that must mean that it has 3 hydrogens to make up the other 4 bonds. And then we look at this carbon, and that carbon must have 2 hydrogens coming off of it because it already has 2 bonds going this way. So we have a CH2. And then down here we have another CH2. And right here, another one of those, CH2. Here, though, we get a little bit different. We've got 3 bonds already, which means we just have a CH. And then coming off of the main chain here is another CH3. And then we finish it off with this CH3. Now we can write this even more condensed because we have a lot of repeating here. This whole section, CH2, CH2, CH2 repeats. So what we can do is call this CH3, then parentheses, CH2 3 separate times, CH, and then we've got a CH3 coming off of it, and a CH3 to end it. And before we name it, let's draw this out in its entirety. So we have C, and then 1, 2, 3, and then another one with a CH3 coming off of it, and a CH3 at the end. So I'll put all the hydrogens in here. Okay, there is my complete drawing, my full structural formula. And so now I can go through and think about all my naming rules. So I know that I have a CH3 group coming off the main chain. And I also know that my main chain is all singly bonded. So I know if I have single bonds, that I have an alkane, which will have a suffix of ane. And then I know that I want to start counting my carbons from the side closest to the thing that is not hydrogens on the main chain. So I want to start counting from this side. I have 1, 2, 3, 4, 5, 6 hydrogens. Oops. 6 hydrogens, or 6 carbons, excuse me. Got thrown off by my ruler there. 6 carbons in the main chain means I have a prefix of hex, or hexane. Okay, then I look at my group here. A CH3 has just 1 carbon in it, and so I have the prefix meth, and since it's coming off the main chain, its suffix is YL. So I am going to put this all together, and my final answer is 2-methyl, because my methyl group is on the second carbon. 2-methyl hexane, because it's 6 carbons that are singly bonded in a row. Okay, this next one is a draw me, and I see a few things right off the bat. I see an ONE, I see a pentan, I see a 3. I see the same things here, pentan, 3, and the one. So I need to remember what each of these things are telling me. My pent, that's coming from either here or here, means that I have 5 carbons in a row. And then when I see this ONE, I know that I have a carbonyl, C double bond O, and it is not on the end. In fact, this 3 is telling me that it is on the 3rd carbon from the end. So let's start drawing it out. We have 1, 2, 3, 4, 5 in a row, and my 3rd one in, so 1, 2, 3, is going to be a double bonded oxygen. And I could have counted from this side as well. I could have gone 1, 2, 3. I end up in the same place. Either way with this one, the 3rd carbon is going to be on the same spot. And then I can fill in the rest of my hydrogens. So we have a hydrogen, a bunch more. This carbon's already complete because of the 2 bonds at the oxygen and the 2 bonds to the neighboring carbons. And then we'll finish this one off. So that's my full structural formula. If I wanted to make that a condensed structural formula, I'm just going to start counting and looking at each carbon from left all the way to the right. So I have here a CH3, followed by a CH2, followed by a carbon that has an oxygen with it, and another CH2, and lastly a CH3. And finally, if I want to put that into a line angle diagram, I'm going to consider each of these carbons a node on my line. So each of those is going to be a node. And we start here with my CH3. My next part of my end of the line is a CH2. And here's my carbon that has the double bonded oxygen to it. And then we have a CH2 and finally a CH3. Again, I don't actually draw in little circles to represent them, but I know that the ends are those things that I highlighted in pink on the other one. So 1, 2, 3, 4, 5 in a row correspond with each of the 5 carbons that I listed on there. And that would be my line angle diagram. Okay, this next molecule is pretty small, and we want to look first at how we convert this line angle diagram to a condensed structural formula. So I see at each of these nodes, I've got carbon and hydrogens to fill it out. And then I also want to remember I've got double bonded oxygen on that final carbon as well. So if I'm looking at my first one, I have a C with 3 hydrogens on it because it already has 1 bond to the next carbon. That must mean it has 1, 2, 3 hydrogens coming off of it. This second carbon has 1, 2 bonds, which means it needs 2 more hydrogens, CH2. And this final carbon has 1, 2, 3 bonds already, which means it just needs 1 more hydrogen. So we have CH, and then we don't want to forget that we've got that oxygen there, so we're going to say CHO. And if I want to make this bigger, a full structural formula, I'm going to draw in all of the lines between showing the bonds and all of the hydrogens. And now we can name it. So I see right off the bat that the C double bond O is a special group it is a carbonyl. So we have a carbonyl, which we know is a C double bond O, and this carbonyl is on an end carbon. Therefore, it is an aldehyde. So I just need to look at the main part of the chain, which is nice and straightforward. I've got that being my first carbon because it's what's attached to the carbonyl. Here's my second carbon. Here's my third carbon. The prefix for 3 is prop. And I know an aldehyde's suffix is Al. So if I put this all together, I have prop and al. Propanal. Okay, we have a lot going on in this draw me. One of the things I see right off the bat is that I have an oic acid. I also see that I have a butane. I have a dimethyl, and I have a 3,3 relating to that dimethyl. So, starting with the base chain, I've got bute, which means 4 carbons in a row, and then I have an oic acid, which means I have both a hydroxyl as well as a carbonyl group, which really just means I have a carboxylic acid. So 4 in a row, 1, 2, 3, 4 for the start of my full structural formula. The oic acid has to go on one of the ends. So I'm going to put that here, my double bond O and my OH. And then this will be, by definition, my first carbon. My second then, my third, and finally my fourth. And it says that my third carbon is going to have 2 methyl groups coming off of it. A di meaning 2 and methyl meaning a CH3. So rather than hydrogens in the spots where I would normally put them on this molecule, I'm going to have a CH3 and a CH3. And I still have to go through and put in my other missing hydrogens, so I see that this carbon is completely full already. It doesn't need any more bonds. This carbon, though, it's got 2 to start with. It needs 2 more, so those are hydrogens that fill in that spot. The third carbon is beautiful with 4 bonds, and the fourth carbon needs 3 hydrogens to be complete. Okay, if we're going to do this as a condensed structural formula, I start going from the left all the way to the right and showing what is on each carbon without showing the bonds. So I have my first carbon with 1, 2, 3 hydrogens on it, CH3. And my second carbon has a CH3 group and another CH3 group attached to it. So I'm going to put those in parentheses because they're coming off of that carbon, CH3, 2. And then my next carbon just has 2 hydrogens coming off of it, CH2. Then my final carbon has the OH and the O, so I'm going to say COOH. And the reason I separate those this way is because that's our general format for knowing it's a carboxylic acid. It helps us to realize that those O's are not bonded to each other, but that they're separated. And then if I want to do a line angle diagram of this, each of those carbons is imagined to be part of the node of the molecule. So here's a CH3. Then I have my C with 2 CH3s coming off of it. And it goes down to another CH2. And then it goes up to a C that has not only an OH, but also a double bonded O. Okay, I see a number of things in this line angle diagram right off the bat. I see that I have a triple bond between my first and second carbon. I also see that I have a 1,2 carbon, so an ethyl group coming off of my third carbon, and I have a 1 carbon group, so a methyl group coming off of my fourth carbon. So I'm going to first put this into a condensed structural formula. Let's see, my first carbon right here has 3 bonds between it and the next carbon, which means it only needs 1 more bond, so we have 1 hydrogen that's bonded to it. Again, we just don't put the hydrogens on the line angle diagrams. And then my next carbon, my second one, already has 4 bonds. It's got the 1, 2, 3, and 4, so that one's satisfied as is. I don't need to put any hydrogens with it. My third carbon has 1, 2, 3 bonds, which means that it needs a hydrogen. And we also need to identify the fact that there is a CH2 and a CH3 coming off of it as well. I just put it in parentheses so that I know it's coming off of that carbon. And then I have my next carbon right here. That carbon has 1, 2, 3 bonds, which means it also needs 1 hydrogen. But instead of a CH2, CH3 coming off of it, it just has 1 CH3 group. So again, it's in parentheses to indicate that it's coming off of that carbon. And then I finish it off with 1 more carbon. And this one has only 1 bond so far, so it needs 3 hydrogens attached to it. CH3. Now if I were to draw out this full structural formula, I'm going to now to put it into a full structural formula from the condensed structural formula or the line angle diagram. I start with my first carbon, which I said has 1 hydrogen attached to it, and then it has a triple bond to our second carbon. And then that carbon has a single bond to our third carbon, and that third carbon, so 1, 2, 3, has a hydrogen, plus on the other side it has that group attached. So I'm going to put a hydrogen on one side, and then a CH2, CH3. And then I've got my next carbon, which has a hydrogen on one, and then a CH3 as well. And then I finish it off with my fifth carbon, which has a CH3. Right there. So now I can go about naming this, and initially I identified a few things. I identified that there was a CH3 group there. I identified the fact that there was a CH2, CH3 group there. And I identified that my main chain, which is right here, contains a triple bond. So, a lot to think about. One of the things I'm going to want to do right off the bat is count how many total carbons are in my main chain. My main chain is going to contain this triple bond here. And since that triple bond is the closest functional group that's attached to the main chain, I'm going to call that my carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And I know that the prefix for 5 is pent. And I know that a triple bond is Y and E. And I know that I have to say what number of carbon that is on, because it could have very well been on my second carbon. So I'm going to say it's on my, first carbon. So it starts on the first one, goes to the second one. And then I look at my other groups here. So this CH2, CH3, that's 1, 2 carbons, and I know that the prefix for 2 is F. And it's 3, the third carbon, ethyl, YL, because it's coming off the main chain. And then I have my group here, CH3. 1 carbon there is a meth. It again ends with a YL because it's coming off the main chain. And I have to identify the number. It's on the 4th carbon. So if I put this all together, I want them in alphabetical order. I've got this 3-ethyl and the 4-methyl. Ethyl comes before methyl, so I'm going to start there. 3-ethyl, 4-methyl, and then I have 1 pentyne. Or if I wanted to, I could call this 3-ethyl, 4-methyl, and then I can include the 1 right next to the Y and E to indicate that it's directly from that. And so I could call it pent 1-ine. I see just a few things going on in this one. I see an E and E. I see pent. And then I also see the 1. So that 1 is telling me that the double bond, ENE representing an alkene, or I see double bond C, it's telling me that that's on the first carbon as I'm counting through my carbons. And the pent, I remember, is the prefix for 5. 5 carbons in the main chain. So if I start drawing this out, I've got 1, 2, 3, 4, 5. In between my first and second carbon, I'm going to have a double bond. And now all I need to do is fill in the rest of my hydrogens. So each carbon needs 4 bonds to be complete. So I can put a hydrogen and a hydrogen on that first carbon. Now it has 4. The second carbon only requires 1. The next 2 carbons both require 2. And finally, my last carbon requires 3. And if I'm going to put this into a condensed structural formula, I want to notice that this repeats. The CH2 repeats twice, so that's going to make my writing of the condensed structural formula a little bit easier. And for that condensed structural formula, I have to look at each carbon individually and write what's attached to it in one nice line. So my first carbon has 2 hydrogens attached to it. My second carbon has 1 attached to it. And again, I said that since this is repeating, CH2, I can put it in parentheses and put a 2 behind it to represent that we've got 1 and 2 right there. And last but not least, my final carbon is a CH3. And then if I'm looking at doing a line angle diagram of this, I want to look at each carbon. So I'm going to have 1, 2, 3, 4, 5 nodes along my chain. And I've got 1, 2, 3, 4, 5. And then I know between my first and my second carbon I have a double bond. So here's my first carbon, here's my second carbon, and there's my double bond. The first thing I want to do is change this line angle diagram into a condensed structural formula, just so we can practice with that. And each of these nodes are the end of the lines where we don't have the oxygen. So the oxygen makes things a little bit different. That oxygen there is just what's at the end of that line. but I'm going to have at all of the other nodes that are blue there, carbons and hydrogens to fill up the total of 4 bonds that carbon needs. So if we start out here, my first carbon has 1 bond to my second carbon, but it needs 3 more bonds, so that means that it has 3 hydrogens attached to it. My second carbon has 2 bonds between the 2 carbons that it has, which means it needs 2 more bonds, CH2. And then my third carbon has 2 bonds, it needs another CH2. And I have my oxygen. And then I go up to my next carbon. It also has 2 bonds, which means it needs 2 hydrogens. This one also needs 2 hydrogens. Same with this one. And finally, my last carbon has 1 bond, which means it needs 3 hydrogens to complete it. If I wanted to condense the structural formula even more, I can look at the fact that I have some repeats. The repeats help me out a bit. So I have a CH2, CH2 in a row, and I have a CH2, CH2, CH2 all in a row. So I can consider those to be repeats. If I had CH3, I can make my life easier by saying CH2 and it goes once, twice, so 2, and then it's my oxygen. And then I have a CH2 1, 2, 3 times, CH2, 3, and a CH3 at the end. Now if I wanted to do the full structural formula, again, we're just getting practice here. So I'm going to do CH3 followed by my CH2. Remember, in the full structural formulas, we have to show all of the bonds and all of the elements that are involved. So this is the most tedious one to draw out, but it also tends to be one that's easier to visualize what's going on when naming it. And that's why I wanted to make these conversions so that we can see what's going on. Now, right in the middle, I've got that oxygen, and going off of it, I've got 2 groups. So hopefully you're thinking to yourself, aha, this is an ether. It is for sure an ether. So ethers have the name where we consider each group on either side of the oxygen to be a YL group. It's like it's attached to the main group. And I just have to go through and count how many of each I have. So on one side, I have 1, 2, 3. The prefix for 3 is pro. So I have a propyl on one side, and then on my other side, I have 1, 2, 3, 4 in a row, and those 4 have a but as the prefix, so butyl. Ethers have ether always at the end of the name, so we can write that out right away. Ether. And then the 2 ill groups have to go in alphabetical order, so I see B comes before P, so this is going to be butyl, propyl, ether. When I see an ill with an O8, I know that I have an ester. And an ester always has this general form of R, O, C, double bond O, R prime. So this bit right here is where I can start anytime I'm drawing out an ester. So I'm going to put that right in the middle, O, double bond C, O. And then I need to remember where the different parts go. So the pentyl is going to come off of the oxygen that's singly bonded to the carbon, and the butanoate includes the carbon that's right there. So I can look at my prefixes. Pent means 5 carbons. Prefix pent is 5 carbons. And so I'm going to have 1, 2, 3, 4, 5 coming off of that oxygen. And then bute is the prefix for 4 carbons in a row, and I already have 1 right there, so I'm going to have 2, 3, and 4. This is almost a full structural formula, but I need to include all of the hydrogens as well to make sure that each carbon has 4 total bonds. So starting from the left, this carbon had 1 bond, which means it needs 3 hydrogens to complete it. Here we have some CH2s, because they each had 2 bonds to start with. And then my oxygen is fine. Oxygen only needs 2 bonds. That means that this oxygen is fine as well. This carbon is also good because it has 4 bonds already. And then we're going to have a couple more CH2s followed on the end with a CH3. Now, if I wanted to put this into a condensed structural formula instead, I can make my life easier, as we organic chemists often like to do, and I can repeat all of these CH2s that are in a row, repeating each other. And here, CH2, CH2. So, we're going to go with the CH3 to start with, and then my CH2 repeats 1, 2, 3, 4 times. So CH2, 4. Then I have my oxygen, and then I have my carbon with my oxygen, and then I have a CH2 repeating just 2 times, 1, 2, and then I end with a CH3. Now, if I want to put that into a line angle diagram, I remember that each carbon is like the node, and so I've got 1, 2, 3, 4, 5 carbons in a row to start. So 1, 2, 3, 4, 5. And then we've got our oxygen. So I'm going to go up part way to my oxygen, and it goes down to my first carbon here. And that first carbon has a double bonded O on it as well. So I'm going to put that in there. And then I have a CH2, CH2, CH3. So that's 3 more carbons. 1, 2, 3. And that is my line angle diagram for this ester pentyl butanoate. This line angle diagram looks funny, doesn't it? Well, I can see that I have 3 nodes, so I'm going to have 3 carbons, and I also see that I have 3 hydroxyl groups. And a hydroxyl group, it's an OH attached to the main chain. And so we're going to have what is called an alcohol. Okay, those 3 carbons that are in a row, let's make this a condensed structural formula first. That's always a good way to look at things. So my first carbon there has 1 bond to the next carbon plus a bond to the OH. That means it needs 2 more bonds to get its complete 4 bonds. So that means there must be hydrogens there that I haven't bothered to write. So CH2, and then I can put it in parentheses that it's an OH that's coming off of that first carbon. Then my second carbon here, let's change up the colors. My second carbon has 1, 2, 3 bonds directly attached to it, which means that it only needs 1 more hydrogen. And then again, we have an OH coming off of that carbon. And finally, my last carbon has 1, 2 bonds, which means it, like the first one, needs 2 hydrogens to complete it. And the OH is now coming off of that one. So a little repetitive here, let's go through and make this a full structural formula, because sometimes that's easier to actually think about as we're naming. So I have a CHHOH, and then I have a COHH, and finally a CHHOH. Okay, so I already said that I have an alcohol, and I know that the suffix for alcohols are OL. And I know that I have 1, 2, 3 carbons, and I know that the prefix for 3 carbons is prop. I also know that I have 1, 2, 3 different OH groups. So instead of just the all, I'm going to have to say that I have 3 of them. And so I call it tri-all, because I have 3 of them. And I have to identify where they are, because really these OHs could be anywhere that there is a single hydrogen on the chain. So I could have a tri-all that was all completely on this first carbon, but they're not. They're spread out, 1 on each of them. So I have to also identify that. So on my first, second, and third carbons, I have 3 alcohol groups. And then I need to not forget what my main chain is. It's a prop. So propan, 1, 2, 3 triol. Or if I don't like how busy that looks, I can go 1, 2, 3 propan triol. Both of those mean the same thing and would allow us to draw that full structural formula.